The best way to prepare for your next mathematical literacy exam is to practice past exam papers. It is often the case that learners discover during the exam that the problems they do in class is nowhere near the level of questions they get asked in an exam, and by that time it is too late to make the change. For example, compare this textbook question with a question from this exam paper we'll be working on in this video. Both questions test your understanding of speed, time, and distance, but the exam problem is more complex, requires multiple steps to solve, and it combines measurements and maps and plans into one question. How crazy is that? To pass your next mathematical literacy exam, you must practice exam papers like the one in this video. But I know it's difficult to understand those written memos that come with past exam papers. And the reason for that is that those memos are not meant for educating learners. Those memos are designed for teachers like me as a guide for marking your script. That is why this video exists. It will help you by explaining in detail how to solve those questions in a way that the memo doesn't. In this video, I'll be walking through the June Mathematical Literacy Paper 2 exam of 2022. And if you didn't know it already, in Paper 2 of your Math Lit exam, you will be assessed on your understanding of measurements, maps and plans, and a little bit of probability. That means no finance, no data handling questions. If you'd like a copy of this exam paper, the link is in the description below. And if there is a particular problem you find challenging, you can find that chapter in the timeline bar. Also, don't forget to subscribe and hit that bell notification to get notified of more videos like this. Now, without further delay, let's get into question 1. Question 1.1 consists of 5 questions designed to assess your understanding of measuring tools and map scales. You are given 2 columns. Column A lists descriptions and column B lists measuring tools and map scales. You will have to match the item in column B with its description in column A. In question 111, you must select the most appropriate scale to draw a map of South Africa. In column B, there are 3 scales to choose from: the bar scale, the ratio scale, and the numerical scale. The bar scale has a scale factor that is most suitable for maps of provinces. The ratio scale of 1 to 50,000 has a large enough scale factor that it's suitable for maps of whole countries. And the numerical scale of 1 centimeter equal 1 meter has a scale factor that is most appropriate for building floor plans. From the 3 options, the most appropriate scale to draw a map of South Africa is D, the ratio scale of 1 to 50,000, because the scale factor is large enough that you can fit the whole of South Africa on an A3 size page. In question 112, you have to select the instrument that is most suited to measure the circumference of a dinner plate. The instrument most suited to measure the circumference of a dinner plate would be E, the flexible tape measure, because it's flexible enough to wrap around circular or cylindrical objects. In question 113, you have to select the most appropriate scale to draw a plan of a house. The most appropriate scale to draw a plan of a house would be G, the numerical scale of 1 centimeter equal 1 meter. In question 114, you have to select an instrument that is suited to measure the width of a soccer field. The instrument most suited to measure the width of a soccer field would be C. This tape measure is used to measure distances longer than retractable tape measures. In question 115, you have to select the instrument that is most suited to measure the length of a pencil. The instrument most suited to measure the length of a pencil would be F, the ruler. Question 1.2 consists of 4 measurement questions that were designed to assess your understanding of the metric system in relation to length, area, and volume. You are given a sketch of a standard brick with dimensions. All dimensions are given in millimeters. In question 121, you have to state which formula A, B, or C can be used to calculate the total surface area of the brick. The total surface area of the brick is the sum of all the areas of all 6 faces of the brick. The formula for option A accounts for the sum of the areas of only 3 faces. The formula for option B accounts for the sum of the areas of all 6 faces. 2 multiplied by 240 multiplied by 70 is the area of the front and the rear side of the brick. The 2 multiplied by 240 multiplied by 212 accounts for the area of the top and the area of the bottom of the brick. And the 2 multiplied by 112 multiplied by 70 accounts for the area of the right side and the area of the left side of the brick. The formula for option C is basically the same as option A. The 240 multiplied by 70 accounts for the area of the front side of the brick only. The 240 multiplied by 112 accounts for the area of the top side of the brick only. And the 212 multiplied by 70 accounts for the right side of the brick only. So the correct formula for the total surface area is B. In question 112, you have to state the unit of measurement for the volume of the brick. The volume of the brick refers to the amount of space it occupies. The volume is calculated by multiplying the length, width, and height together. This will give you the unit of measurement for the volume of this brick as cubic millimeters. In question 123, you have to calculate the length of the brick in meters. You have to remember that there is 1000 millimeters in 1 meter. So the length of the brick in meters is 240 divided by 1000, and this equals 0.24 meters. In question 124, you have to determine the maximum number of rows of bricks that can be stacked height-wise to a height of 2100 millimeters. The maximum number of rows is 2100 millimeters divided by 70 millimeters, and this equals 30 rows. Question 1.3 consists of 5 measurement questions that were designed to assess your understanding of the metric system. You are given a recipe for baking scones. There is a list of ingredients and a baking instruction. In question 131, you are instructed to convert the mass of the flour to kilograms. The mass of the flour is given as 500 grams. There is 1000 grams in 1 kilogram. So the mass of the flour of 500 grams is equal to 500 divided by 1000, and this equals 0.5 kilograms. In question 132, you have to determine the number of large eggs needed to make 30 scones. For the ingredients listed here, the number of scones you can make is 1 dozen. Now you should recall that a dozen equals 12, and you have 2 large eggs for this recipe. So the number of eggs needed to make 30 scones is 30 divided by 12, then multiplied by 2, and this equals 5 eggs. In question 133, it is given that each scone has an average diameter of 7 centimeters. You have to write down the average radius of each scone. The radius of a circle is half its diameter. So the average radius of each scone is 7 centimeters divided by 2, and this equals 3.5 centimeters. In question 134, you are instructed to calculate how many full dozens of scones can be made with 500 grams of butter. For a dozen scones, you will need 75 grams of butter. So for 500 grams of butter, you will be able to make 500 grams divided by 75 grams, and this equals 6.67 dozen scones. But the question asks you how many full dozen scones can be made. So you have to round this number down to the nearest dozen, so the answer will be 6. Why 6 and not 7? Because if you round up to 7, then you will need more than 500 grams of butter. But rounding down to 6, you will have some butter left over, but that's okay. In question 135, it is said that the scones were placed in the oven to bake at 10 minutes past 2 in the afternoon. You are instructed to write down in words the time the scones were placed in the oven. Writing this in words will give you 10 minutes past 2 in the afternoon. Question 2.1 consists of 5 maps and plans questions and 1 probability questions that were designed to assess your understanding of road map interpretations. You are given a roadmap of the route of a mini marathon in Annexure A. In question 211, you have to write down the starting time of the mini marathon using the 24-hour format. The starting time is given as 2 p.m. on the map. This time in the 24-hour format is written like this. In question 212, you have to determine the number of places where an ambulance can be found. The symbol for an ambulance is this. You can now simply count the number of locations where an ambulance can be found. The number of locations is 8. In question 213, you have to state the mode of transport that is not allowed on the mini marathon route. It clearly states here that the use of bicycles during the race is not allowed. So, bicycles. In question 214, it is stated that the distance of a standard marathon is 42.2 kilometers. In question 214a, you have to determine in simplified form what fraction of a standard marathon a mini marathon is. On the map, this symbol indicates a kilometer marker. So the total distance of a mini marathon is 10 kilometers. Why 10 kilometers? Because this marker indicates the 9th kilometer mark, and at the 9 kilometer mark you are given a note that says that it is 1 kilometer to go to the finish. So the fraction of a mini marathon to a standard marathon is written like this. Simplified form means that this fraction should be written in a form with whole numbers in the numerator and denominator. To achieve this, you will have to find the lowest whole number that, when multiplied with 42.2, will result in a whole number. This lowest whole number is 5. So multiplying both the denominator and the numerator by 5 will result in a fraction of 50 over 211. This fraction is the simplified form of the mini marathon to the standard marathon. In question 214b, you have to give one reason why the mini marathon is called a mini marathon. One reason could be that the mini marathon is a fraction of a full marathon. In question 215, you have to write down the letter that best describes the following statement. The probability of a runner crossing the railway line during the mini marathon is A, definite, B, 0%, or C, 100%. From the map of the mini marathon, you will notice that the route of the marathon does not cross the railway line. So the probability of a runner crossing the railway line during the mini marathon is B, 0%. Question 2.2 consists of 7 maps and plan questions designed to assess your understanding of layout plans. You are given a layout plan of the village of Irene on Annexure B. Some of the streets end in dead ends, also known as cul-de-sacs. The arrows in these streets indicate that traffic can flow in one direction only, so they are one-way streets. You are also given a compass where east points towards the top of the page. Normally the top of the page is given as north, but here it's given as east. You are also given a list of other places of interest on the plan and a key indicating the entrance of the school and the railway line. In question 221, you are instructed to write down the place of interest that is situated at the corner of Krieger Street and Bruce Street. On the corner of these two streets, there is a building that is allocated as number 4. From the list of other places of interest, this place is known as the Scout House. In question 222, you have to give the general direction of the Bastion Guest House to the station and shopping center. The Bastion Guest House is located here, and the station and the shopping center is located here. The general direction of the Bastion Guest House to the shopping center is southeast. In question 223, you are asked to name the street that the railway line cross. This street would be Nelmapius. In question 224, you have to write down the name of the church in King Street. The church in King Street is labeled number 5. From the list of other places of interest, the place labeled number 5 is the St. Martin's Church. In question 225, you are given a set of directions to follow and to identify the place it leads to. The directions are as follow. Drive from Irene Pre-Primary East along Crawford Street. Turn left into Queen Street. Take the first right into Stanley Street and continue to King Street. Turn right into King Street, pass 5 streets and then turn left. Finally, continue across the first street. Before the next intersection, Busiswe will be waiting for David. The place that this leads to is Irene Hall. In question 226, it is stated that the actual straight line distance, or as the crow flies, from the entrance of Irene Pre-Primary to the entrance of Irene Primary School is 1.9 kilometers. You are then instructed to determine, rounded to the nearest thousand, the scale of the layout plan in the form of 1 to the value of the scale factor. Here, as a crow fly means a straight line distance between Irene Pre-Primary to the entrance of Irene Primary School. Using a ruler to measure the distance between these two locations will get you a value of about 8 centimeters. To write down the ratio of the map distance to actual distance, you first have to convert the actual distance from kilometers to centimeters. The reason you want to do this is because the ratios compares two or more values of the same unit. Since the actual distance is given in kilometers and the map distance was measured in centimeters, you have to either convert kilometers to centimeters or centimeters to kilometers. Here I choose to convert kilometers to centimeters. The actual distance in centimeters is 1,9 kilometers multiplied by 100,000. Why 100,000? Because there is 100,000 centimeters in 1 kilometer, and this will give you an actual distance of 190,000 centimeters. Now the ratio of map distance to real distance can be written as 8 centimeters to 190 centimeters. Since both units are the same, you can now write the ratio without units. Now when you divide both sides of this ratio by 8, you will get a scale of 1 to 23,750. Now according to the instructions given in the question, you are required to round this value to the nearest thousand, so the final answer would be 1 to 24,000. In question 2 to 7, you have to explain why the driver traveling along King Street cannot turn right into Bruce Street. The reason for this is because the other vehicles will be flowing in the opposite direction to the way the driver is traveling, because it's a one-way street. Question 3.1 consists of 2 measurement questions and 1 probability question that were designed to assess your understanding of perimeter and area of a rectangular shape and the circumference and area of a circular shape. You are given 2 types of window frames in the shape of a rectangle and circle. The dimensions of the rectangular window frame are given in centimeters, while the dimension of the inner diameter of the circular window frame is given in millimeters. In question 3.1.1, you have to determine the perimeter of the rectangular window frame. The formula used to determine the perimeter of a rectangle is this. The width of the rectangle is 149 centimeters, while the length of the rectangle is the sum of A, B, and C on this diagram of the window frame. So the length of the window frame is 55 centimeters plus 99 centimeters plus 55 centimeters, and this equals 209 centimeters. The perimeter is then equal to 2 times the sum of 209 centimeters plus 149 centimeters, and this equals 716 centimeters. In question 3.1.2, you are instructed to calculate the inner area in squared centimeters of the circular window frame. Now the first thing you should do is to convert the inner diameter of 605 millimeters to centimeters. Now you should recall that there are 10 millimeters in 1 centimeter, so the inner diameter is 605 millimeters divided by 10, and this equals 60,5 centimeters. Now the formula for the area of a circle is this. In this formula you need the radius, but you are given the diameter, so you will have to calculate the radius of the circular window frame first. The radius is a straight line drawn from the center of a circle to its circumference. The radius is therefore half the diameter. So the radius is 60,5 centimeters divided by 2, and this equals 30,25 centimeters. Now substituting this value into the area formula, you will get the following equation. So the area of the circular window frame is 2,875,126375 squared centimeters. In question 3.1.3, you are told that one of the window panes of the rectangular window frame broke. You have to write down the probability as a decimal that it is not one of the window panes that can open. The total number of window panes is 7, and the number of window panes that cannot open is 3. So the probability that it is not one of the window panes that can open is 3 divided by 7, and this equals 0,4285714,286. But you can round this number up to 0,429. Question 3.2 consists of 2 measurement questions and 1 combination of measurement and finance question. These questions were designed to assess your understanding of budgeting and planning in relation to renovation of rooms in homes. You are given a situation where a person intends tiling the floor of a dining room and lounge. You are given the dimensions of these floors in meters. You are also given some information on the dimensions of the tiles, its cost and other material, and the labor costs as well as the total budget for the project. In question 3-1, you are instructed to show that the floor area to be tiled is 32 square meters. You are given a formula to assist you in solving this question. Now, the total floor area of the dining room and lounge combined is the sum of the area of the dining room and lounge. So the total floor area is 4 times 5 meters plus 3 times 4 meters, and this equals 32 square meters. In question 3.2, you have to determine how many boxes of tiles will be needed if an extra 10% of the number of tiles must be added for cutting and breakage. Now, to calculate the number of tiles needed to cover the total area, you will have to divide the total floor area by the area of one tile. To do this, both the units of the area of the floor and the tile must be the same. Now, the total floor area to be tiled is 32 square meters. The dimensions of the tile is given in centimeters. You have to convert this dimension to meters. So if you can recall that there are 100 centimeters in 1 meter, so 35 centimeters is 35 divided by 100, and this equals 0.35 meters. Now the area of one tile equals 0.35 meters multiplied by 0.35 meters, and this equals 0.1225 square meters. So the number of tiles needed to fill the total area is 32 square meters divided by 0.1225 square meters, and this equals 261,22448 tiles. Since you will need an extra 10% for cutting and breakage, you will have to multiply this value by 110% over 100%. Why? Because if you consider 261,22448 tiles as 100% of the tiles needed to tile the floor, then an extra 10% added to this will give you a total percentage of 110%. So the total tiles needed, including the 10% for cutting and breakage, is 261,22448 multiplied by 110% over 100%, and this equals 287,346928 tiles. Rounding this value up to a whole tile will give you a total number of tiles that must be bought of 288 tiles. Now the reason why we round up and not down is because if we round down, we will not have enough tiles. And if we round up, we will have an extra bit of tiles left over, and that's okay because it's better than having too little tiles. Now from the information, it is given that there are 4 tiles in a box. So the total number of boxes needed is 288 divided by 4 tiles in a box, and this equals 72 boxes. In question 323, you are instructed to show by means of calculation whether the budget is enough to finish the tiling project. Now the total budget of 15,000 Rand must cover the whole project, including tiles, cement, grout and labor. Now the cost of the tiles will be 72 boxes multiplied by 143 Rand 84 cents per box, and this equals 10,356 Rand 48 cents. The tile cement costs 99 Rand 90 cents per 20 kilogram bag, which covers 3 square meters. So the total number of bags needed for this project is 32 square meters divided by 3 square meters, and this equals 10,7 bags. Rounding up to the nearest whole bag will give you a total of 11 bags. Now the total cost for the tile cement would be 99 Rand 90 cents multiplied by 11 bags, and this equals a total cost of 1,098 Rand 90 cents. It is given that 4 bags of tile grout is needed for this project at 89 Rand 90 cents per bag. So the total cost for the grout needed will be 89 Rand 90 cents multiplied by 4 bags, and this equals 359 Rand 60 cents. The total labor cost is given as 2,500 Rand for the whole project. So the total cost for the whole project will be 10,356 Rand 48 cents for the tiles, plus 1,098 Rand 90 cents for the cement, plus 359 Rand 60 cents for the ground, plus 2,500 Rand for the labor, and this gives you a total cost of 14,314 Rand 98 cents. Since this value is less than 15,000 Rand, we can say that the budget for this project is enough. Question 4.1 consists of 4 maps and plans questions that were designed to assess your understanding of layout plans. You are given a layout plan in Annexure C that shows the seating plan for a cinema during the COVID-19 pandemic. The seats marked with an X needs to be left vacant in order to comply with social distancing regulations. In question 411, you have to state on which side of the cinema is seat E4 from E15 when a person is facing the screen. E4 is to the right of E15. In question 412, it is assumed that pre-COVID conditions apply and all seats are occupied. In question 412A, you have to name the row and seat number of the middle seat in the 8th row from the screen. Given that it is before COVID conditions, all seats would be available for use. The 8th row from the screen would be K. The number of seats in row K is 21, so the row and seat number in the middle of this row is K11. In question 412B, you are instructed to write down the ratio of the number of wheelchair spaces to the number of seats for patrons not in wheelchairs. There are 4 seats allocated to wheelchairs, and the total number of seats that are for patrons not in wheelchairs is calculated as this. Since you are required to give the ratio in the format of wheelchair spaces to the number of seats for patrons not in wheelchairs, the ratio will look like this, 4 to 130. Now, if you divide both sides of this ratio by 2, you will get a simplified ratio of 2 to 65. In question 413, it is stated that on Friday evenings before COVID, all seats in the cinema, not including the wheelchair spaces, were always occupied. With this information in mind, you have to calculate the percentage of income lost due to social distancing during the pandemic if all the tickets for the seats were equally priced. The number of seats in the cinema was calculated to be 130 in question 412B. The number of seats that will not be occupied during the pandemic was 66 seats. So the percentage of income that was lost is 66 divided by 130 multiplied by 100, and this equals 50,76923,077%. You can simplify this percentage to 50,77%. Question 4.2 consists of 1 maps and plan question and 3 measurement questions that were designed to assess your understanding of volume and surface area of cylindrical tanks. You are given a diagram of a cylindrical diesel tank. You are told that the tank needs to be painted. 2 dimensions are given in meters, and you are also given the following information. The stand and all external attachments are made of stainless steel and will not be painted. The base area of these external attachments is 1 square meter. 1 cubic meter equals 1000 liters, and all dimensions shown are outer measurements. In question 421, you have to state the purpose of the breathing valve on the tank. This valve allows air inside the tank to escape as the diesel is pumped into the tank. In question 422, it is stated that the steel used to make the tank is 5 mm thick all around the tank. And for safety reasons, the tank is filled to 95% of its capacity. This means that the tank can only be 95% full. In question 422A, you have to show that the inside diameter of the tank is 3,21 meters. From the diagram, the outside of the tank is given as 3,22 meters. Since you know that the thickness of the tank is 5 mm all around, this means that the inside diameter will be the difference between the outside diameter and the thickness here and here. Before you can subtract the thickness from the outside of the diameter, you will first have to convert the unit of thickness from millimeters to meter. You should recall that there are 1000 millimeters in 1 meter, so 5 millimeters equals 5 divided by 1000, and this equals 0,05 meters. Now the inside diameter of the tank is the outside diameter of 3,22 meters minus 2 times the thickness, and this will give you an inside diameter of 3,21 meters. In question 422b, you have to calculate the maximum liters of diesel that this tank can hold according to the safety regulations. You are given this formula to use. The volume of a cylinder equals 3,142 multiplied by the radius squared multiplied by the height. In the formula, the radius of the tank is equal to half the inside diameter of the tank. From 422a, the inside diameter of the tank is 3,21 meters. So the radius of the tank is 3,21 meters divided by 2, and this equals a radius of 1,605 meters. Now the height of the tank is equal to the outside length of the tank minus the thickness of the steel on both sides of the tank. The height of the tank is therefore equal to the outside length of 7,25 meters minus 2 times the thickness of 0,005 meters, and this equals a height of 7,24 meters. Now substituting the values of the radius and the height into the given formula, you will get the following equation. Volume of the diesel equals 3,142 multiplied by the radius of 1,605 meters squared times the height of 7,24 meters, and this equals a volume of 58,599622782 cubic meters. But this value is not according to the safety regulations. In order to comply with the safety regulations, this value must be reduced to 95%. So the maximum safe volume for this tank will be 58,599622782 multiplied by 95 over 100, and this equals a volume of 55,66964 cubic meters. But you have to convert this value to liters as required by this question. So from the information, 1 cubic meter equals 1,000 liters. Therefore, the maximum liters of diesel this tank can hold safely is 55,66964 cubic meters multiplied by 1,000, and this equals 55,669.64 liters. In question 423, it is given that the external surface area of the tank, excluding the base area of the external attachments, need to be painted. The spread rate of the paint is given as 3 square meters per liter. The manager states that he would need less than 30 liters of paint to complete the task. You will have to verify by showing all calculations whether the manager is correct. You are also given this formula for calculating the surface area of a cylinder. The surface area of a cylinder in square meters equals 2 times 3,142 times R plus the sum of R plus H, where R is the external radius and H is the external length of the tank. Looking at the diagram of the tank, you will notice that the tank has all these external attachments. External attachments are parts that are attached to the outside of the tank. Now, because these parts are attached to the outside of the tank, you cannot get to the surface area that these attachments cover. To get to the surface below the attachments, or in other words, the base of the attachment, you will have to remove the attachment from the tank, and this is not practical. What the question wants you to do is to calculate the area to be painted excluding these areas below the attachments. So what you will have to do is calculate the total surface area of the cylinder, then minus all the little areas covered up by these attachments to find the total surface area to be painted. The surface area of the tank is calculated using this formula here. The surface area of a cylinder in square meters equals 2 times 3,142 times R plus the sum of R plus H, where R is the external radius and H is the external length of the tank. Since the external diameter of the tank is given in the diagram, this only leaves a radius to be calculated. The radius is half the diameter, so it is 3,22 meters divided by 2, and this equals 1,61 meters. Now substituting these values of the radius and height into the formula, you will get the total surface area of the tank, including the surface area covered by the external attachments, equal to 2 times 3,142 times the radius of 1,61 meters, multiplied by the sum of the radius of 1,61 meters plus the height of 7,25 meters, And this equals a total surface area including the area covered by the external attachments of 89,6387464 square meters. Now from the information given below the diagram, the area covered by the external attachments is equal to 1 square meter. Remember that this is the area that cannot be painted. So the area of the tank that should be painted is equal to 89,6387464 square meters minus 1 square meter, and this equals 88,6387464 square meters. From the statement, the spread rate of the paint is 3 square meters per liter. So the number of liters of paint needed to paint this tank equals 88,6387464 square meters divided by 3 square meters per liter, and this equals 29,5462488 liters. This value can be rounded to 29,55 liters. Since 29,55 liters is less than 30 liters, you have to state that the manager is correct. If you don't make this last statement, you will lose 1 mark. Question 5.1 consists of 1 maps and plan question, 1 measurement question, and a probability question. You are given the dimensions of a bakkie and the inner dimensions of a garage where the bakkie is to be parked. The dimensions of the bakkie is given in millimeters, while the dimension of the garage is given in meters. There is a missing value D that represents the space between the wall of the garage and the side of the bakkie. In question 5.1.1, you have to identify the view of the bakkie that is represented by the dimensions 1815 mm by 1860 mm. These dimensions are the height and the width of the bakkie. The view that is represented by these dimensions is the front view. In question 5.1.2, you are instructed to calculate the value of D, which is the space between the sides of the bakkie and the sides of the wall of the garage if the bakkie is parked exactly in the middle of the garage. The value of D is equal to the difference between the width of the garage and the width of the bakkie divided by 2. But the dimensions of the width of the bakkie has to first be converted from millimeters to meters. You should recall that there are 1000 millimeters in 1 meter, so the width of the bakkie in meters equals 1860 millimeters divided by 1000, and this equals 1,86 meters. Now the value of D equals 3,6 meters minus 1,86 meters divided by 2, and this gives you a value of 0,87 meters. In question 5.1.3, it is stated that you can choose a color and a window tint for the bakkie. The bakkie comes in 4 colors: white, black, blue, and green. The windows can be tinted using 35% tint or 50% tint. You have to state how many different choices there are for this bakkie. The number of different choices for color and window tint equals 4 colors multiplied by 2 types of tint, and this equals 8 choices. Question 5.2 consists of 4 maps and plans questions and 1 measurement question that was designed to assess your understanding of strip charts and speed, distance, and time problems. You are given a strip chart with the road distances in kilometers from Windhoek to Springbok. Springbok is a town in South Africa and Windhoek is a town in Namibia. The border between South Africa and Namibia is shown on the map. Keys are given for the symbols used on the chart. N or B indicates national or highway roads. C indicates gravel roads, and the squares indicate places of interest. The speed limit on national roads is 120 km per hour and on gravel roads 80 km per hour. The distances in kilometers between towns on the N7 and B1 are given alongside the chart, and the distances of the roads that branch off the N7 or B1 are given by the numbers next to the road. And finally, towns are indicated by circles on the chart. In question 5.2.1, you have to state one difference between a strip chart and a normal road map. A difference between these two types of maps is that a normal road map is drawn to scale while a strip chart is not. In question 5.2.2, you are instructed to determine the distance between Springbok and Gobabis. To travel from Springbok to Gobabis, you will have to travel along the N7 and B1 to Windhoek, and then from Windhoek to Gobabis along the B6. So the distance from Springbok to Gobabis equals 892 kilometers from Springbok to Windhoek, plus 203 kilometers from Windhoek to Gobabis, and this equals a total distance of 1095 kilometers. In question 523, you have to identify the Namibian town found on the border between South Africa and Namibia. This is the border between South Africa and Namibia. The Namibian town found on the border is Noordhoever. In question 524, you are given the details of someone's trip. This person left Solitaire at 4 o'clock in the morning and traveled 140 kilometers south on the C14. She then turned right and traveled 289 kilometers east on C19. At Mariental, she turned and drove to Keetmanshoop and arrived at 25 minutes past 12 in the afternoon. In question 524a, you have to calculate the total distance traveled during this trip. The total distance traveled from Solitaire to Keetmanshoop is equal to 80 kilometers from Solitaire to Cesarium, then 60 kilometers from Cesarium to Sossusvlei, plus 180 kilometers from Sossusvlei to Maltahe, plus 109 kilometers from Maltahe to Mariental, plus the distance from Mariental to Keetmanshoop, which is 644 kilometers minus 427 kilometers, which gives us a distance of 217 kilometers. This will give us a total distance of 646 kilometers. In question 524b, it is stated that this person traveled on different types of roads and she maintained the average speed limit prescribed on these types of roads. Letitia stated that she took 3 breaks that were approximately 25 minutes each. You will have to verify showing all calculations whether this statement is correct. You may use the following formula: time equals distance divided by speed. From the key given below the map, you will note that the type of road traveled from Solitaire to Mariental is a gravel road. So if Letitia traveled within the speed limit, she traveled an average speed of 80 kilometers per hour. You will also note that the distance traveled for this part of the journey is 140 kilometers plus 289 kilometers, which gives us a total distance travel of 429 kilometers. So the average time taken to travel the distance is 429 kilometers divided by 80 kilometers per hour, and this equals a time of 5,3925 hours. Now the distance between Mariental and Keetmanshoop is 644 kilometers minus 427 kilometers, and this equals 217 kilometers. You will also note that the type of road traveled between these two towns is a national highway with an average speed on this type of road being 120 kilometers per hour. So the time taken to travel between these two towns would be 217 kilometers divided by 120 kilometers per hour, and this equals a time of 1,8083 hours. Now the time it will take to travel all the way from Solitaire to Keetmanshoop would be 5,3625 hours plus 1,8083 hours, and this equals a total time of 7,1708 hours. You can convert this time from hours to hours and minutes. 7,1708 hours equals 7 whole hours plus 0,1708 of an hour. 0,1708 of an hour equals 0,1708 multiplied by 60 minutes in an hour, and this equals 10,248 minutes. Rounding this time to the nearest minute will give you 7 hours and 10 minutes. Now 3 breaks of 25 minutes each equals 75 minutes, which equals 1 hour and 15 minutes. So the total time it took to complete this trip, including the 3 breaks, equals 7 hours and 10 minutes plus 1 hour and 15 minutes. This equals 8 hours and 25 minutes. Now from the details of the trip in question 524, Letitia left Solitaire at 4 o'clock in the morning and arrived at Keetmanshoop at 25 past 12 in the afternoon. So the time it actually took to make the trip in hours and minutes equals 8 hours and 25 minutes. Since the calculated time equals the actual time stated by Letitia, You have to write down that the statement made by Letitia is correct. If you do not make this last statement, you will lose 1 mark. Thank you for taking the time to watch this video, and if you found this video helpful, you can subscribe to be notified of more videos like this, and you can check out this video next.